Cool. Hello, everyone. My name's Todd. Hopefully going to share some insights of what I've learned over the last 2.5, 3 years working with Angular. It's been my weapon of choice. I have tried React, so it's good to follow that talk. I won't make any jokes. So today we're going to be looking at the performance parts. So it's quite sort of in-depth. If you haven't used Angular before, I would recommend sort of looking at the, well, basically on the last slide, I've got a link to the site with the full deck in. I actually gave this presentation last week, which was 50 minutes long. This is had to cut some stuff out, obviously, to fit it in today. So if you check out the full deck after this, but yeah, this is the short and sweet version. Quick about me, I currently work in England for a company in San Francisco. A lead engineer there. We've got a semi-big AngularJS application. I'm a GDE, so sort of involved in the Google side of things. If you've got any questions afterwards, you can feel free to tweet me at ToddMotto pretty much anywhere. I also write quite a lot of JavaScript articles, especially Angular. You can grab that on toddmotto.com as well. So today, if you've used Angular probably for a short term, you might have seen the word digest or watchers from a sync queue that might have cropped up. So we're going to kind of dive into that to begin with and actually understand what things in Angular impact the performance. So it's not just a sort of, here's a cool API, let's use it. Kind of look at teaching developers how the things that they write actually impact the performance, so we're going to look at that. I went on a recent application migration from version 1.2. We jumped 1.3, we went straight to 1.4. So I've uncovered quite a lot of new performance features in that. So we're going to look at some of those and the impacts that they have. Quick wins, there might be a simple one-liner that you'll just go, wow, yeah, let's integrate that today. Tips and tricks, structure practices, and some advanced techniques. So let's skip to the very happy man, jump in at the generic changes that have happened from 1.2 to 1.3 and above. So first off, who's actually using Angular day to day or has used it recently in applications? Show of hands. So yeah, probably about half of you. Brilliant, cool, you should come and sit at the front. Who out of you lot are actually supporting IE8 in your applications? No one. Perfect. I saw someone point. OK, so from 1.2 to 1.3, they basically dropped all the IE8 support, which was fantastic. That removed a lot of, we'll call it junk, from the source code. These stats were taken from Angular 1.3, so it's around 4.3 times faster to do all the DOM manipulation stuff, 73% less garbage collection, and the digest loop, which is kind of the main thing in Angular, which controls all the dirty check-in, keeps our data in sync. That's now 3.5 times faster. I haven't done any testing against the later versions. They're releasing a 1.5 at the moment. That should be even faster. 78% less garbage in that, and over 400 bug fixes, which is pretty good for just a sort of minor version jump. So let's look at the kind of performance-driven Angular. So it's not just sort of, yeah, here's a cool feature that might speed up your application if you use it correctly. It's actually sort of thinking and sort of investigating an API before you use it and say, am I going to write really bad code if I use this, if I just skip over the docs? We won't go into Angular docs. So yeah, this was a majestic quote that I pretend I came up with. Understand what impacts performance before you code. So like I just said, don't sort of gloss over the documentation. The docs in Angular have been improved tenfold in the last couple of releases. So actually dig into them. They've got loads of live embedded examples. If all else fails, you've got the Angular source code. It's not particularly horrendous to actually look through. The actual source code is fully commented, which is actually what generates the documentation. So you can actually see the code that they're actually talking about if you dive a little bit deeper. Hopefully, you don't feel like whoever this person is. when you think about the digest cycle. So let's look into the fundamentals of what we call the digest loop, watchers. You might have seen $watch. These kind of play together. And a sync queue, which I think is 1.3, Angular introduced the eval sync. So we'll come to understand those shortly. But first, we have a really boring diagram of a browser. So here's our browser. A browser has an event queue. Let's assume that the user's clicked a button or a change event is fired. We then enter the JavaScript execution context. Angular, obviously being angular.js, sits inside the JavaScript execution context. Everything that executes inside Angular happens inside this $apply function. So if you've written like a jQuery plugin inside a directive, you've probably called scope apply by yourself. Everything such as an ngclick will happen. Angular will call this for you. What happens then, it calls our function. This might be ngclick equals do something. Do something is then called. We then enter the mystical digest cycle, or the digest loop, which essentially loops over all the bindings in the current view, for example. I like to use a list of emails as like an example to actually kind of illustrate it in your minds as I kind of talk. So if you imagine you've got a page with a search box, that's one binding. You've got 1,000 emails in your inbox. Angular's going to loop all over these when something is changed via the user. If anything's changed that affects these, we're then going to, next slide, we're going to re-render the DOM. So the digest loop might happen once, it might happen twice, it might happen 3 times. Angular will cut you short, throw an error if it's happened 10 times. Otherwise, you're going to spin an infinite loop. So you're going to have probably bad code on your hands and needs a refactor. Then we go all the way back to the event queue, and then the user might type something else. So there's quite a lot happening in a very short space of time. If you think you've got an input and somebody types hello, you've actually caused a digest once, twice, 3, 4 for each letter in hello. So after all these, I kind of sum them up. So some of them I might talk about with the code examples as we carry on. So the digest triggered by scope apply and the built-in events. We iterate the watchers array. If you console log the scope, when you're actually in development, you can actually see all the watchers, so it's quite interesting. If the model is different from the last calculated value, Angular will execute the listener. We exit the loop, repaint the DOM. The watcher side, so if you've got a controller with scope.something, scope.something, these don't actually get added to the watchers until you're using them in the view. So here we've got an example, view/event bindings, curly braces, and foo. So anything there is dirty checked. What we want to use at the bottom is minimize the use of watchers. When you tend to hit around 2,000, which can be done very, very easily, if you've got 1,000 emails with chunks of repeated code, basically, they're going to duplicate watchers tenfold. You'll start to see UI lag. If people are doing like fuzzy searches in an input box, you're going to see like the UI thread's basically going to block, and you're going to see lag before anything actually changes, which is obviously bad for the user. Cool. So there's something, the async queue, which actually runs first in the digest cycle. So all these async things, they get flushed out to begin with. We'll then carry on with the digest cycle. If something in that digest might call a sync function, we'll go back to the beginning and flush that out. So onto the performance side, with actual things we can do whilst developing in Angular. So someone mentioned earlier they were building a website which had quite a lot of items on. It was an ng repeat. What you can actually use is this track by expression. If you see at the end, you've got track by user.id. Without that, let's assume you have I think it was gog.com's homepage. So let's say you've got 1,000 items there. If a 1,001 item appeared, what Angular would do was destroy the entire DOM collection and then repaint 1,001 items, which is really, really bad for performance. So what we can do is use this track by expression, user.id. what it does is associates everything inside the user object will have like a unique ID, we'll assume, at the end. When that 1001 item comes in, Angular knows it's not going to destroy the entire DOM, it's just going to inject that one item. So that's a massive performance improvement. And there was a bit of a debate about the whole React so much faster thing. If you use track-by, you're looking at very, 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 very similar speeds to React. So keep that in mind. Track-by minimal DOM repaints uses the object references instead of Angular's kind of made-up stuff underneath, which it doesn't really do as well as doing it yourself with a unique property. OneTime bindings. These are superb. These came in 1.3. So you can see it's quite easy to use. You've got : vm.name. What this essentially does, when vm.name, so it could be Todd, when that becomes available, it's not undefined anymore. Angular will say, yeah, we've rendered it. We'll go back in. It basically returns a closure. The closure gets called, and then we unbind it from the expression. So it's like a static render, like a one-time thing. If you've got like an emails inbox and you want to render the name inbox at the top, if you don't want to hard code it, you might support different languages, for example. So you one-time bind it, it's going to remove it from your watchers, you're going to get that digest loop a lot faster. These are just some examples, how to use it inside an ng repeat with ng class, so it's like a one-time render thing. That's pretty much summed up there. If you look at the fifth point, one time, not one way, a lot of people have tweeted me saying, oh, well, how do Angular one-way bindings work? And it's important to know the difference. It's one-time binding, not a one-way, so it's not like a one-way downwards flow. It will actually render it, and then it basically is dead to Angular. ng model options. So one of the coolest things about Angular is the whole form validation, how they create all these things for us to keep track of. So ng model options is pretty new. I think it was 1.3 again. So here, I mentioned earlier that we might have an input box. We type some letters in, and it's going to digest, it's going to digest, it's digest, and we're just wasting resources if we don't actually need to do anything. What we can specify here is we want to actually update the model on the default event, which is just a user typing, or a blur event. And the special part here, you can see the debounce at the bottom. So every 250 milliseconds, which is what the 250 corresponds to, we're then going to go and update the Angular model. It's going to force a digest, and we're going to save a load of UI resources. The blur event is going to execute immediately, 0 milliseconds. We've also got this quite a nice method called I don't know why I'm reading it there, I can't read it, rollback view value. So what Angular does during this kind of wait period is it keeps track of the changes. So if someone's making a change to their username and you say, no, we're not going to change it to that because it's a stupid username, we can call rollback view value. It's a bit of a mouthful. It looks like Java. And then what it basically undo all the changes in the input for you, and you get the immediate feedback. Fine-tune how the model updates are done. We can define all the event types ourselves. Add in the debounce is a massive, massive performance increase, especially if you're dealing with like an array. If you're doing an ng repeat and you're searching for that, you could debounce it somewhat. Cool. Bit of a boring one, this one. ng-show and ng-if. It looks quite boring, but they're actually quite different and powerful in different ways. The easiest way to explain these comes back to this whole watchers thing. So we want to try and minimize the watchers, keep Angular quick. If we use ng-if, what it'll actually do, Angular will destroy the DOM node. If we need it back, it'll then inject it and reconstruct it. This might not be good for something like navigation that is being used really frequently, whereas ng-show might be. The difference with ng-show, there is obviously the ng-hide sort of brother, whichever. So yeah, if we use an ng-show, the value is false. Angular is going to add a class name. What it's going to do is hide that. We've got an ng repeat inside with, let's say, 500 watchers. All that Angular's done is added a class. It's hidden, so it's in the DOM still, which means it's still being looped over in the digest, which is just a complete waste of resources. nice bullet points on that. I won't go over those again because we pretty much nailed those. I've got 15 minutes left to try and crank this all in. Yeah, this was quite an interesting find, actually. I came across this a few months ago. There's a performance test. The link's on the next slide. So I've actually started using ngbind instead of the handlebar syntax. Obviously got handlebars at the top, VM, VM.username. So, and then you've got the p tag underneath, ngbind equals vm.username. They're much the same. They do exactly the same thing. Difference is Angular has to do some extra parsing on the first item. It needs to do like a regular expression check. It will get rid of the white spaces either side of that. Whereas with ngbind, the process is actually a little bit simpler. The performance benefit of using this comes down to the perf example at the bottom. So it says, welcome ngbind to Facebook. That might say, welcome Todd to Facebook. At this point, you've got ngbind, which is just one element. There's one thing that Angular is keeping track of. If you were going to use the handlebars, what Angular has to do is keep track of that entire string. So it's going to find welcome Todd to Facebook. If something's changed, it's going to have to replace the entire text node, which is just a waste of time again. So we can be smarter. We can use ngbind, put it in the right places. The third point, well, yeah, actually, if you check out the ngperf, it's got a lot of tests and stuff. I didn't want to include them in here because nobody likes looking at tiny numbers in the DevTools console. So ngcloak as well, it lessens the need for ngcloak, which is kind of what we'd use if our application's rendering, and you might have seen the curly braces happening. We can use ngcloak, and then the curly braces disappear upon rendering. This is probably one of the coolest one-liners that you can inject. We inject it into the config stage. It's to be used with $HTTP, so we can inject the provider for that. I showed you eval async earlier. There's also apply async. So here we're just telling HTTP provider to use the apply async method. So what does it look like? That's all you need to do. What does it actually do? Let's assume you're making, I don't know, 10 GET requests when you've hit a search page, for example. Angular's going to go, yep, I'll go and get that URL, go and get that piece of data, go and get that one. What it's going to do, as soon as that's resolved, it's going to come back, it's going to call a digest cycle. The next one's going to resolve maybe 20 milliseconds later. It's going to call another digest. So what Angular does is be smart. It pushes all these into a sync queue. Anything that resolves within 10 milliseconds of each other, it will actually push into the queue and then force one digest at the end. So if all those 10 requests happen to finish within 10 milliseconds of each other, it doesn't sound like a lot, but it happens, we can then save maybe 9 digest cycles, which is beneficial for the user and any ancient computers that they're actually using. That's summing up on that one. Another magical one-liner, exactly the same similarities to the previous one. Just inject the compile provider and call the debuginfo enabled false, which is a bit of a mouthful. Could just debug disable or something, make it a bit clearer. So what does this do? When it's enabled, you've obviously been inspect element. You see all these bindings that Angular binds to it. So you get all this ngScope class, ngbinding, ngisolate scope on the my directive example. And then when you disable it, you can see in the next code chunk, there's none of these classes. Why does it do this? Yeah, Angular uses, it recommends that you use Karma and Protractor, which with Jasmine to basically do your unit testing. How it does its unit testing, when you say I expect A to equal A dot B or whatever, it will actually go and instantiate your elements, hook into these like ngScope, ngbindings, and then does all its calculations that way. You'll also be able to, in the DevTools console, you can inspect an element, and then you can call, for example, on my directive, you could call the method getIsolateScope. You then get the scope object returned to you. And this wastes a lot of resource at runtime. So you can actually speed up your page initial rendering by disabling this, all with one line. And there was an article floating around that actually said that they got a 50% page load speed increase by just this one-liner. There used to be a little, I think it was about 6 or 7 lines of code that you could do if jQuery.data and hack around it, but they actually realized that this was a massive performance benefit, so they actually included this native debuginfo enabled method that you could call. If you in production, for example, and it's disabled, you can actually call Angular reload with debuginfo. It'll then reload the page. You get all the bindings there. It's obviously temporarily, but that comes in a lot of handiness. One of the coolest things about Angular when you first start off is all the power with filters. You can use a filter on ng repeat. You can use it on basically anything. Here, if we take a milliseconds date stamp, 1441, etc., we can use the pipe filter, we can say date, and then we can give it a format, which is really, really simple. The bad thing about this is that filters actually run twice per digest. Said the word digest too much today. So yeah, it will run each DOM filter twice per digest. If you were to do the filter inside the actual JavaScript controller, which handles this data, it's only going to run once, which is exactly what I recommend doing. So if we look here, we've got some controller, we've used dependency injection, we've injected the $filter provider, and then instead of doing vm.date, pipe date, and then letting Angular do all that stuff, we can do it in JavaScript, which is a lot simpler. It makes the testing a little bit simpler because we don't have to sort of rely on the 2 different values. We've got the milliseconds in the controller, we got the parsed output in the DOM. We can just have the same format. So create a local variable. Obviously, if you've got a huge set of data, you can map through it and do all this stuff for yourself. There's a local variable called time. And then we're going to call the filter with date. We can obviously create our own filters if they're a bit more complicated. We pass in the time object and tell it what to render out. And it's as simple as that, and we just use it. We've saved ourselves another digest. Thing is, if you've got like an email client, which I've actually built for the workshop tomorrow, with 1,000 emails that are all got a date stamp, this is actually going to cause, and well, this is where maths precedes me. I think it's, yeah, another digest per filter, which is unnecessary. We just need one. Done. Yeah, we've done those 3 steps. Cool. So hopefully, I've got 6 minutes left. So hopefully from this, we've understood the digest loop a little bit more. It is a complicated beast. If you check out the source code on GitHub for Angular stuff, it's a crazy beast, and they've got actual comments saying insanity warning. This does actually work. We've got tests to prove it. So we've looked at the performance side of some of the directives. I wasn't managed to get them all in from the initial talk. Consider using the JavaScript over the DOM bindings. If we can parse as much as we can before we send it to the DOM, it's going to make it a lot simpler. Anything that is bound to the DOM is actually gets pushed into the watchers array, which is then dirty checked. So if we can make that process a bit simpler, it's going to benefit Angular, and it will be a lot happier for you. Cool. As I said, the speakerdeck.com/topmotto. This I won't upload this talk because it's slightly shorter, so you might as well check out the fully packed version with the extra information in. If you do check it out and there's questions, at topmotto on Twitter, and you can ping me there. So yeah, cool. Thank you.